improvements in the use of technology for conventional sources of energy. We know that wood has been used as a convenient source of energy for a long amount of time. If we can somehow assure that a large number of trees are planted, we can ensure that wood is available for fuel for a long amount of time. Likewise, given the large livestock population in India, if we can find a way to use the biomass generated by the livestock in the form of cow dung, we can ensure a renewable and environmentally friendly source of energy. However, both wood and biomass have their own problems. Let us understand what these problems are. Wood is not a very efficient fuel. It does not produce a very large amount of energy per unit mass burned. Also, normally wood burns with a lot of smoke, and this smoke is dangerous for health. It is also very less efficient compared to burning other sources such as petrol and coal. So in order to increase the efficiency of burning wood, we can convert it into charcoal. If you heat wood in a vacuum, we can remove all the dangerous volatile materials in the wood and be left with almost pure carbon, which we call charcoal. Charcoal burns with a very clean flame, does not produce dangerous smoke, and overall has a higher energy efficiency compared to wood. In many regions of northern and rural India, cow dung dried into small pellets is a very common source of heat energy. The problem, just like wood, is that cow dung does not burn very efficiently and produces huge amounts of smoke, which is dangerous for the health of people living in these places. A way to improve the energy efficiency of this biomass-based fuel is the use of a biogas power plant, also called a gobar gas plant. In this plant, a mixture of cow dung and water is fed through a special pipe into an enclosed structure. Special bacteria are added, such as methanobacters, which ferment this cow dung water mixture in the absence of oxygen to produce large amounts of methane gas and some carbon dioxide and hydrogen sulfide. The methane gas resulting from this process can then be tapped directly from the gas plant and used for various purposes, such as heating. The gobar gas plant is a method by which we can convert a large amount of animal-based biomass into a more efficient fuel. It is renewable because livestock is also a renewable resource. On the other hand, these plants also come with their own set of problems. Number one, most Indian farmers are marginal with very few heads of livestock, and the gobar gas plant is economical only if you have a large number of cows or buffaloes to work with. Second, the fermentation process also creates some amount of carbon dioxide and hydrogen sulfide. Both of these gases combine with moisture present in the slurry to form carbonic acid and sulfuric acid, which over a period of time will damage and degrade the metallic fittings used in these plants, which means that a gobar gas plant will have long-term maintenance issues. Wind energy. When we hear the words wind energy, many of us have an idea that it is some kind of a non-conventional modern source that has become popular only recently, forgetting that humans have been using sailboats for at least 4,000 years. And countries like the Netherlands, which we also call Holland, is called the land of windmills because they use large numbers of windmills to pump water out of their country, which actually exists below the sea level. So wind energy has been used for a long amount of time, which is why we consider it to be a conventional source of energy. Today, the most visible method by which we use wind energy are windmills. A windmill at its basic is simply a large fan which is connected to an electric dynamo. Wind impinging on this fan causes the fan to rotate, and this rotation is used by the dynamo to create electrical energy. Windmills are aesthetically pleasing. They can be set up in a relatively short amount of time, and wind is basically free, which makes wind energy a rather attractive conventional source of energy. But as with everything else, wind energy also has its problems. First of all, wind, though found everywhere, is never found everywhere all the time. There are seasonal variations in the amount of wind an area gets, and even in the single day, the amount of wind flowing will vary from time to time. Unless the wind has a minimum speed of at least 15 kilometers per hour, you can't really use it efficiently to drive a windmill. So the number of places where you can set up a windmill are relatively few. Also, you have to cover a relatively large area in order to get a usable amount of energy. Generally, it has to be a minimum of 2 to 3 hectares. So while wind energy can be convenient for some locations, it may not be convenient for others. Also, windmills require costly installation and the various parts will wear out over time. So there are finite and considerable maintenance expenses in the long term. This means that wind energy, while useful in some places, is not exactly a solution that can be used everywhere.